Hello, all. Under the track of sustainability, today I'll be discussing generative AI workflows for climate risk modeling in food systems. 2024 was likely the first calendar year recorded 1.5 degrees centigrade above the pre industrial baseline, with cascading extremes affecting agriculture and logistics. This is now the operational backdrop for our DevOps decisions. Today, I will show how to embed generative climate intelligence into CI/CD and Git so that the risk modeling, downscaling, and stakeholder briefings is reliable software. I'm Poshan, a data AI and analytics architect working at the intersection of enterprise platforms and climate resilience. Focus today from models to maintainable systems, climate ML from that is DevOps plus MLR. The challenge climate volatility and that threatens food systems. Insecurity remains stubbornly high. Sophie shows hunger in 20 and 2.3 billion experienced moderate or severe food insecurity. Affordability of healthy diets remains a critical constraint. 2024 shattered climate records shows that compounding droughts, floods, and heat stress that hit production, storage, transport. WMO emphasizes early warning and climate services as vital for protection. The engineering takeaway is that our data ML systems must anticipate extremes, quantify uncertainty, and continuously adapt them. The convergence opportunity to start with climate data availability, ERA5 provides hourly globally analysis since 1940 at around 31 km with uncertainty estimates and near real-time updates ideal for historical baseline and features. Sentinel-2 offers 10 to 20 multispectral L2A surface reflectance with frequent revisit greater for vegetation, stress signals, and soil moisture. CMIP6 scenarios define futures for emissions, socioeconomics for forward-looking stress testing. The second, the generative and ML weather climate. GraphCast GNN delivers 10-day global forecast outperforming ECMW greater than 90% of targets and running in minutes. Google Weather 3D Transformer achieves nature published accuracy orders for magnitude speedups. Neural GCM, a hybrid physics ML, runs weather and climate stably for multi-decade metrics with big efficiency gains. Cordriff for kilometer scaling downscaling for precipitation and near surface fields critical for farm level risk. Finally, the DevOps maturity, the GitHub standardization, and policy as a code. Let's treat models like software with tests, rollouts, and rollbacks. We all use agro workflows for Qflow, KSOF. So, being said that, the core capability one is the climate scenario model. Build synthetic extreme event ensembles by conditioning on CMIP6 SSP trajectories and back testing against ERFI. Use Cardiff to downscale global fields from local precipitation temperature extremes. Use GraphQL to generate rolling 10-day perturbation sets for operational planning for mid-century stress tests, sample SPS, and bias correct. How do we validate? Compare synthetic extremes to historical analogs from ERA5 and even archives quantify distributional fidelity with a high frequency long record helps here. From technical output to field ready intelligence, ingest use CDS APIs for ERA5, Copernicus data space, Sentinel Hub for Sentinel-2 plus soil, water rank databases, generate scenarios, produce drought, food, heat, and assembles via chord rip downscaling and GraphCast nowcast. Both are traceable in CI because they are model crop response, link weather stress indices, example, hot degrees days, SPI to yield models, or agronomic rules translate into management actions. Translate, produce farmer-friendly maps, Sentinel-2 LGA-based layers, and policymaker briefs summarizing risk and ROI for interventions. Core capability 2, adaptive strategy generation. Localized interventions synthesized by LLM agent workflows crop rotation, irrigation timing, heat-tolerant cultivars, and risk-sharing instruments, conditioned on hydrology, soils, and economics. FOO's 2025 disaster assessment underscores raising shock across crops, livestock, and aquaculture. Strategy engine should explicitly reason over multi-hazard context, localized intervention recommendations, crop rotation mapped to soil, biotic pressures, irrigation tied to season outlooks, and soil moisture, seed selection aligned to phenology under high hard drought and financial leave, practiced by vulnerability, aligns again with WMO FAO emphasis on early warnings and climate service for agri-food resilience. Core capability 3. Automated brief generation. Use LLM to compose stakeholder specific briefs, farmers, what, when, like sourcing, risk, like budget, return of investments, NGOs, right? Include uncertainty bands, references to scenario IDs, and data provenance to satisfy governance and audit trails. So DevOps integration architecture, transition, agro workflows for container native DAX like ingest, generate, downscale, evaluate, brief. It's a CNCF graduated Kubernetes native and battle tested. Kubeflow pipelines V2, where you want to reusable ML components and experiment tracking. Serving K-Serve for standardized auto-scaled interface supports both predictive ML and LLM generative endpoints with canary rollouts and explainers. Agro CD to keep cluster state synced with Git pipelines, model services, drift detection, and self-healing. Model registries, Azure ML registry, model registry for cross workspace promotion and lineage like DevDesk, AWS Sage approvals, and CI/CD integration. Practical implementation considerations like model versioning and promotion, Azure ML, register models as a set, promote via registry across workspace with lineage, SageMaker, use model registry with staging constructs and approval gates, integrates with Event Bridge for approvals. Scalable serving, K-serve inference services for GraphCast, Pangu, Cordriff, and policy LLMs, request-based auto-scaling and canary rollouts, continuous testing and data quality, run drift checks on features and predictions using Evidentify, fail the pipeline and significant shift observability. Use Agro Prometheus metrics, surface dataset, plus models, version IDs, in brief, metadata, track, extreme, explicit. Real world impact across the ecosystem. Tie outcomes to stakeholders, planting windows, variable rate irrigations, seed selection, insurance triggers, supply chain routing, align messaging with WMO 2024 framing, invest in early warning, plus climate services, and deliver actionable localized guidance via your platform. The path forward, governance and safety built in, operational trust using NIST ARMF 1.4, govern, map, measure, manage, and the 2024 generative AI profile for LLM specific risks. Map these controls to your pipeline stages. Publish model cards for each climate LLM component, intended use, data metrics, and API metadata. Key takeaways: integrate AI into pipelines, treat climate LLM artifacts like software, version, tested, promoted via GitHub's Agro CD ensures desired state stays synced. Focus on practical outputs, farmer ready visuals, Sentinel 2, size policy briefs with uncertainty and ROI. Enable continuous adoption, monitor data and concept back as needed, and registries. To conclude, generative AI DevOps gives us reliability